Hi, welcome to this lesson on categorical and quantitative variables. In the previous lessons, you've already learned quite a bit about the variables that we use in our statistical tests. For instance, you learned about how you should visualize categorical or interval variables. In this lesson, I want to explore these topics some more. This is in preparation for the next module, where we will be talking about different statistical tests, such as the t-test, correlation analysis, ANOVA, and more. Each of these tests are performed with a certain type of variable, whether it's a categorical variable or an interval variable. That is why it's important for you to understand more about these different types of variables and how they look like in an HR setting. So, let's get started. Let's start off with the categorical variables. Categorical variables can be categorized as either nominal, dichotomous, or ordinal. Nominal variables are variables that have two or more categories, but which do not have an intrinsic order. I spoke about this type of variable in Module 1. For example, you could categorize the departments of your company into sales, HR, or marketing. This means that the department variable is a nominal variable with three categories. As you can see, it would be weird to order these departments, as there's nothing to order them by intrinsically. Another example of a nominal variable will be classifying where people live in the United States by state. In this case, there will be many more levels of the categorical variable, 50 in fact. Dichotomous variables are nominal variables which only have two categories. For example, if we were looking at gender, we would categorize somebody as either male or female. This is an example of a dichotomous variable. Another example might be if we asked the person if they completed a recent training. In this case, we may categorize training completion as either yes or no. Dichotomous variables can be assigned the numerical values of 0 and 1, which turns it into a subcategory of a dichotomous variable, namely a binary variable. Binary variables can be useful in data analysis, such as regression analysis, as it gives you quantitative data to work with, rather than qualitative. Ordinal variables are variables that have two or more categories, just like nominal variables, only the categories can also be ordered or ranked. One of the most common examples is the Likert scale, where people can answer a statement by saying that they either completely disagree, neutral, agree, or completely agree. You will find this in many surveys, both in companies as well as outside. Another example could be education level. Education level might be categorized as elementary school education, high school graduate, college graduate, and graduate degree. However, whilst we can rank the levels, we cannot place a value to them. We cannot say that a high school graduate is twice as educated as an elementary school education, for example. Now let's continue to continuous variables. Continuous variables are also known as quantitative variables. Continuous variables can be further categorized as either interval, ratio, or discrete variables. I've spoken about interval variables before, where I mentioned how you would visualize them in histograms. Interval variables are variables for which their central characteristic is that they can be measured along a continuum and they have a numerical value. For example, intelligence measured in IQ. IQ is a continuum, as there's an equal distance between each value. For example, the difference between 90 and 100 is the same as between 100 and 110 with IQ. However, IQ is not a ratio variable. Ratio variables are interval variables, but with the added condition that 0 of the measurement indicates that there is none of that variable. So intelligence measured in IQ is not a ratio variable, because an IQ of 0 does not mean that there is no intelligence. Age, however, is a ratio variable, as the age of 0 indicates that that person hasn't been born yet. Otherwise, they would have had the age of 1 day, 2 weeks, etc. Other examples of ratio variables include height, mass, distance, and many more. The name ratio reflects the fact that you can use the ratio of measurements. So, for example, someone who is 34 years old is twice the age of someone who is 17 years old. Finally, we have discrete variables. A discrete variable is a variable that can only take a certain number of values. This can be 1, 2, 3, but not 2.5. For example, the amount of people in a department. This can be 10 people, 5 people, but it can never be 7.5 people. How would you have a department that's 7.5 people? This is what makes it a discrete variable. Other examples include the number of applicants who applied for a vacancy, or the number of errors in a draft for a new course. Now you know more about the different types of variables. This will serve you well in the next module, where you will learn about multiple statistical tests. Like I said in the beginning, each test only works with certain variables. Knowing how these variables work will help you to understand how certain statistical tests work. For instance, you can't do a t-test with categorical variables, or an ANOVA test with just interval variables. This means that you may have to collect your data in a different way to accommodate for the statistical test. But more on that in Module 3 and 4. That's it for this lesson. In this lesson, I covered both categorical and quantitative variables. Categorical variables can be either nominal, dichotomous, or ordinal. Nominal variables are variables that have two or more categories, but which do not have an intrinsic order. Dichotomous variables are nominal variables, which only have two categories, and ordinal variables are variables that have two or more categories, just like nominal variables, but the categories can also be ordered or ranked. Continuous variables can either be interval variables, ratio variables, or discrete variables. In the next lesson, I will go more in depth on variables in relation to one another. See you there!